So many of the trends that we've been talking about are leading up to the idea of bonding. And the first type of bonding we'll discuss is ionic bonding, which is the bonding between ions. So bonds in general are any sort of force that holds groups of atoms together to make them one unit, one molecule essentially. So ionic bonds involve a transfer of electrons. So one atom gives up its electrons to a different atom which takes the electron, and then they attract due to charge. And then another one which we will get into soon is covalent bonds, where they share electrons. So all bonding typically tries to fulfill the octet rule, where atoms have a preference towards having 8 valence electrons. Okay? So either through gaining or losing electrons, those atoms fulfill their octet rule and then attract each other with their positive and negative charges. Generally speaking, we've talked about this already, metals lose electrons and make positively charged cations, and then our nonmetals are typically what gain those electrons, forming negatively charged anions. It's the general trend, though there are some exceptions to this rule. So, a very common ionic bond is that of table salt, or sodium chloride. Sodium has 1 valence electron, chlorine has 7 valence electrons. So sodium would much prefer to give up its 1 electron, and chlorine would be very happy to grab 1 extra electron to fulfill their outer valence shells. Okay, so what that looks like is the sodium with its 1 valence electron will give that electron to the chlorine. Alright, so that'll drop the sodium back down 1 more shell that already has 8 electrons in it. The chlorine picks up an extra electron, and now they have their fulfilled octets. They're happy. However, the sodium has a plus charge, the chlorine has a negative charge, so they attract, which what makes the ionic bond. Okay, so the ionic bond is formed by that attraction. So another word for that is electrostatic attraction. Right, this is a fairly strong attraction, though covalent bonds are stronger. Alright, ultimately, you know you've done the ionic bonding correctly if your charges cancel out. Okay, so the net charge, all of these ionic molecules have no overall charge. Okay? So some samples of ionic compounds, some common ones that you might see is magnesium chloride. So magnesium has a 2+ charge, and then chlorine has a minus charge. So if you think about it, we have 2 electrons to give to the chlorine. Alright, now chlorine only takes 1 electron, which means that we need 2 chlorine atoms in order to actually even out and make that, neutral molecule. So the formula for this is actually MgCl2 for the molecule. Alright, you don't write the ionic charges in the formula name or the formula abbreviations. You just have to make sure that you have the appropriate number of atoms bonded together to ensure that it's neutral. So all molecules should be neutral, which is why you don't need the ionic bonds or the ionic charges. So another one is sodium oxide, which kind of works the opposite way. Oxygen makes a 2- ion, so it needs 2 electrons to take from something else. Sodium can only give up 1 electron, so you need 2 sodiums, or Na2O, to make sodium oxide. And then a little bit of a trickier one, something say like aluminum sulfide. Aluminum has 3 electrons it can give away. Sulfide only needs 2. Alright, so what this ends up happening is if you kind of think about it like these were fractions, you've got 1/2 and 1/3. The least common denominator that they have is 6, so we need to find out some combination that gives 6 electrons away and picks up 6 electrons. So for aluminum, since it's 3+, you'd have to have 2 aluminums, and sulfur, since it's 2-, you'd have to have 3 sulfurs to get that to 6. So the formula would be Al2S3. So you should already know this from our valence and ion discussion, but just in case you need a refresh, remember everything in group 1 makes a +1 ion, everything in group 2 makes a 2+ ion, everything in group 3 makes a 3+ ion. Carbon's group makes, and mind you, these are the Roman numerals, carbon's group can go 4 ±. To be truly honest, carbon really doesn't make ionic bonds. It typically is used in covalent bonding. But once you get past carbon, then you get back into having things that form pretty decent ionic bonds. So nitrogen's group makes a 3- ion. Oxygen's group makes a 2- ion, and chlorine's fluorine's group makes a 1- ion, which you can see those here. So again, if you understand the trends on the periodic table, this isn't something you have to memorize. So take these practice problems, see if you can come up with the ionic molecule that this should make. So keep in mind, everything needs to cancel out. So if you've got 2 positives, there needs to be 2 negatives. Okay? I'll give you the answers in just a moment, but if you want to pause this and see if you can come up with them on your own, try that. So potassium is K+, chlorine is minus, so we've got 1 positive, 1 negative, so the formula would be KCl. So fluorine is 1-, calcium is 2+. Oops. So we have 1- and 2 positives, so in order to make that cancel out and be neutral, we would need 2 fluorines and 1 calcium. One thing that will come in handy, and as we get into naming will become more familiar, the positive cation always goes first. So it'd be CaF2. So cation is always written first. So sodium bromide, bromine, we have Na plus, and bromine makes a minus. So again, this is nice and easy. You just need 1 of each. So sodium bromide. Then we have barium and chlorine. Barium makes a 2+ cation. Chlorine makes a -1 anion. So we have 2 positives. To cancel that out, we'll need the 2 negatives, which means we need 2 chlorines, or barium chloride. And last one, phosphorus and calcium. We have Ca2+, P3-. So this one is another kind of complicated one. There's no easy way to double one and leave the other the same, so you got to think about their least common multiplier. That'd be 6. So to get 2+ to 6, we'd have to have 3 calciums, and then to get the phosphorus to 6, you need 2 of them. So it'd be Ca3P2. So just some structural information about ionic compounds. All right, they form a very like rigid crystalline structure. Alright, so there's salt and all other. Salt is actually a generic term for pretty much any sort of ionic compound, but sodium chloride salt forms this really nice, just perfectly lined up combination of your sodium next to your chloride. Alright, and it just forms this perfect crystal-like pattern. Alright, and pretty much all ionic compounds do this. Right? In some ways, what it does is it actually helps strengthen their relationship. It also, coordinates the positive and negative, positive and negative, positive and negative. And what this structure does is give ionic compounds certain traits that other things like covalent bonds don't necessarily have. So their ionic compounds always have a crystalline structure, and because of this, their melting points or their boiling points are generally very high. Sodium chloride has one of the higher boiling points, or particularly melting points as far as things that we may work with. Because of the positive and negative nature, they are good electrical conductors. Okay? And then also because of that positive and negative nature, the water molecule, which is actually a covalent bond, but that has, if you remember from biology class, the partial positive and the partial negative. Alright, that water molecule can sit there and break the ionic pieces apart a little bit because it can interact with the positive sodium and the negative chlorine with the polar parts of the water molecule, which is why it's very easy to dissolve ionic compounds. Right? Salt water is very easy to make. Okay? So make sure you have some notes in class and take the online quiz.